Okay, now we're going to learn about exponential decay and how to calculate growth factor when it's not immediately obvious by looking at the table what it is. So let's say that a smartphone loses about 40% of its value each year. This is reasonably true. What this means is that if you bought a smartphone for $300, a year later, it would be worth 40% less than that if you were to try and buy the same smartphone again, or if you were to try and sell it. So let's make a table to represent the situation. This is an example of exponential decay because the quantities are decreasing instead of increasing each time. So in year 0, we buy the phone for $300. After 1 year, let's see, how do we calculate this? So if we're losing 40%, we could do 300 times 0.4. That gives 120, but we're losing that. So it's 300 minus 120 gives us 180. That feels like too many steps. We should be able to get straight from the 300 number to that 180 number without having to both multiply and subtract. So if I'm losing 40%, that means I must be keeping 60%. Losing 40% is the same as keeping 60%. And if we multiply by what we want to keep, that'll get us straight to the answer. So 300 times 0.6 gives us exactly 180. So this is how we take a percent change and we turn it into a growth factor. So I can continue doing this. So I'm multiplying by 0.6, and then I can do it again, multiply by 0.6. So after 2 years, it would only be worth $108. After 3 years, it would be worth 64.8 times 0.6. And let's do one more. What would it be after 4 years? Now we're down to 38. I'll round it to 0.9. So often these will end up in kind of weird fractions and you're just going to round as you go, but keep the original number to do your next calculation if you can by just doing like times answer, and then it'll keep pulling the correct number. Okay. And if we were to graph this, we don't need to make a fancy graph, but hopefully we can kind of picture what's going to happen here. So if we have years and money, we start 0 is at 300, 1 is at 180, 2 is at 108, 3 is at 64, 4 is at 38. We can see how it's kind of curving as it goes down. So we can draw this in like so to show that it is making an exponential decay curve. There is once again going to be an asymptote here, right? Hypothetically, according to the model, the phone is never going to lose all value, but once it drops below like 1 penny, then we would probably consider it to be valueless, right? So it never technically hits 0, but in practice it would. But there is still an asymptote here mathematically. All right, now we need an equation. So we learned how to write equations. It's the same format. It's just coming up with that multiplier is a little bit trickier, but we already did that part. So our equation, we always do A times B to the power of X. So in this context, 300 is our starting value, and then 0.6 is the B, because that is our growth. All right, now let's think a little bit about how B is going to change. So right now, this was kind of close to like half. If this number had been a really small number, if it had been like 0.1, you can picture how it would have been, we would have been losing value much more rapidly, right? It would have like stayed really close to the x-axis. So, and if B have been closer to 1, the closer to 1 it goes, the less value it would be losing each time. So it would like stay pretty close to 300 and only go down slowly. So in general, B values, when B is more than 1, so if B was 2 or 3 or 10 or 15, then we'd have exponential growth, right? It would be going up. If we have B values that are less than 1, that's when we have decay. So growth will be going up, decay will be going down. Growth goes up, decay goes down. And in both situations, the closer you get to 1, the closer it is to just being a flat line. So the slower the growth happens, either increasing or decreasing growth, which would be decay. So like the slower it's growing or the slower it's decaying, the closer you are to 1. All right, let's do another example. So let's say this time I give you a table and I want you to write the rule. All right, so I've given us a table. I've told us that on day 1, there's 600 of something. Day 2, 450. Day 3, 337.5. Day 4, 253. That might be a rounded number, but close enough. Now notice, I haven't told you either the growth factor or the starting value because I started at 1, not at 0. So in order to find that growth factor, we're going to know that we're going to be multiplying by some B value, and it must be the same B value in order for this to be exponential. So let's check each pair. So 600 times B must equal 450. If I divide both sides by 600, that would mean that B must equal 0.75. Okay, that seems reasonable. Let's check the other one. You can see what ended up happening here was I was dividing the second value by the one before it, right? By dividing the later value by the one right in front. So I'll do that on this one too. 337.5 divided by 450. And hey, look, once again, I get 0.75. That's great. This is checking to confirm that this is in fact exponential. I can do my last one just in case, 253 divided by 337.5. And ooh, I didn't quite get what I wanted that time. So this time it came out to 0.749, but that's probably because this number got rounded, right? Because as we're dealing with exponents, things are not going to stay nice, right? Like eventually it's going to get weird. So that's close enough. We're going to say that our B value is 0.75. So that means my equation is going to be y equals a times 0.75 to the power of x, but I need to know what a is. I don't have it here, but I could go backwards, right? I know that if going forwards, I'm multiplying, we just did this, so I'm multiplying by 0.75. Then going backwards, I could divide by 0.75 to get what I want. So 600 divided by 0.75. And when I do that, I get 800. And I could check my work by doing 800 or 600 divided by 800 and confirm that that gives me 0.75, but it does. So that must be my A value. So y equals 800 times 0.75 to the power of x. All right, practice problem time. All right, so for your practice problem, we have a bank account that loses 1/10 of its value each month. Maybe it's being spent or something. I want you to write a rule representing the situation. Oh, I need to tell you a starting value. It starts with $1,000. Don't be afraid to make a table first to help you look at it if you need some help. Good luck.